Today we are looking at Isaac Newton's third law of motion. This law is most commonly recognized by a simple phrase that states, "For every action there is an equal but opposite reaction." A more extensive definition for this law is that every force occurs as one member of an action/reaction pair of forces where the two members of this pair act on two different objects, and the members point in opposite direction and are equal in magnitude. To put this clearly, in a system with two objects, the force of the second object on the first is going to be equal in magnitude, but opposite in direction to the force of the first object on the second object. This can be represented by the following force equation. The force of object A on object B is equal to the force of object B on object A. Newton's third law is fairly common in the real world. Although we may not see the forces in a quantifiable or explicit manner, we see the results of the law. Some real-world examples of this law include a bird flying in the air, a swimmer committing a turnoff of the pool wall, and the action of someone walking.
Here we see a foot on the ground as a person walks. In this system, the foot is object 1 and it will be interacting with the ground, which is object 2. When a person is walking, their foot pushes down on the ground with a certain amount of force. In reaction to that force, the ground pushes back on the person's foot with the same amount of force. The reaction force of the ground pushing back on the person's foot is what causes the person to move as they walk. The deeper meaning for why this force causes the person to move forward is accredited to Newton's second law of motion, but that's a story for another day. We can see in this diagram that both forces are equal, but force B is an opposite reaction to force A.
Here is a still image of a bird in the air. In the system, the wings are object 1, and they will be interacting with the air, which is object 2. The bird flaps its wings downwards and pushes down on the air. This is a downwards force from the wings to the air. In reaction to that, the air pushes back up on the wings with equal force. This is an upwards force from the air to the wings. The force up on its wings lifts the bird in order to fly. In this diagram, we can see the same relationship between force A and B, where they are equal magnitudes but opposite each other. Here we have a still image of a swimmer after performing a turn. In this system, we have the swimmer's feet as object 1, interacting with the pool wall as object 2. When a swimmer pushes with their feet on the wall of the pool, there is a certain force interaction from the feet to the wall. In reaction to that force, the wall pushes back with the same magnitude of force onto the feet. This reaction force is what makes the swimmer move as they continue their lap. In this diagram, we can see that the pattern from each of the other diagrams continues. The forces, A and B, are both equal in size and opposite of each other. This example, along with the other two, have demonstrated the existence of Newton's third law in real life and how it is applied to each system. What we haven't seen is the law in effect explicitly and quantitatively.
Since we don't get a quantitative value when observing natural third law examples, we must perform a test of our own to get these values. We predicted that the same pattern and observations seen in the natural examples would exist in the test, and Newton's third law would once again be supported.
The test performed used 2 force scales and a closed door. This system consisted of the hand of a person and the door. In order to see the force values, 2 scales were used. Scale number 1 was attached to the door, and scale number 2 was attached to the first scale and held by the hand. Scale number 2 showed the force value of the door pulling back on the person's hand, and scale number 1 showed the force of the person pulling on the door. From this test, we are able to see that as the person's hand would pull harder, the force values of each scale would increase at the same time and to the same values. This meant that the force of the hand pulling on the door was equal to the force of the door pulling on the hand. This diagram of the forces in the system show how the forces were equal to and opposite of each other. The values of the forces, as marked by the scales, were the same, and the forces were pulling on different objects in opposite directions.
After observing natural real-world examples and performing a test of our own, we were able to deduce a couple of things.
We noticed that in a system where two objects interact, there will always be a reaction to the force from the first object to the second object. This reaction is the force from the second object to the first that is both equal and opposite the first force. The second is that the real-world examples and the test performed supported Newton's third law. We were able to observe, test, and confirm this law as they all obeyed the law's parameters.